Office users in the future may be wearing brain scanners in the workplace. A wearable brain scanner that lets computers detect overload and accordingly address their burden and generally make them happier workers. Researchers at the Massachusetts Institute of Technology, MIT, and Tufts University are experimenting with a way for computers to sense anxiety or work overload in humans and change environments automatically. Their system, called BrainPut, is designed to recognize when a person's workload is excessive and then automatically modify a computer interface to make it easier. The researchers used a lightweight portable brain monitoring technology called Functional Near-Infrared Spectroscopy, FNIRS. This determines when a person is multitasking. An analysis of the brain scan data was then fed into a system that adjusted the user's workload at those times, i.e. a computer doing more work when the user was stressed. It can actually learn to give you a break, the technology review added. Technology review said other ways a computer can detect overload includes loggers errors in typing, and speed of keystrokes. This can work in conjunction with the headset. Also, it could use the computer to detect facial expressions. BrainPut tries to get closer to the source by looking at the brain directly, said Erin Tracy Solovi, a postdoctoral student researcher at MIT. Solovi presented the results of the Computer-Human Interaction Conference in Austin, Texas. For an experiment, Solovi and her team incorporated BrainPut into virtual robots designed to adapt accordingly to the mental state of their human controller. The main goal was for each operator capped with FNIRS headgear to guide two different robots to a maze and find the location of a Wi-Fi signal that was strong enough to send a message. Making the hard task hard was the two robots needed to be guided around the maze and not crashing into walls, for instance. When the research subjects drove their robots towards the strongest Wi-Fi signals, their FNIRS sensors transmitted information about their mental state to the robots. The robots were designed to detect when the human was dual tasking, or branching as it is called. When the robots sensed the driver was branching, they took on more of the navigation themselves. The researchers found that the robot's autonomous mode kicked in, the overall performance of the human robot team improved. The drivers didn't seem to notice or get frustrated by the autonomous behavior of the robot when they were multitasking. Technology Review said, a good chunk of computer and human-computer interaction research these days is focused on giving computers better senses so they can do either implicitly or explicitly augment our intellect and assist with our tasks, says Desney Tan, a researcher at Microsoft Research. Tan added, this work is a wonderful step forward toward understanding our changing mental state and designing interfaces that dynamically tailor themselves so that the human-computer system can be as effective as possible. Potential uses? Solovi suggests that such a system could potentially be used to help drivers, pilots, and supervisors of unmanned aerial vehicles. This could help accidents and generally antagonistic behavior. Future work will investigate other cognitive states that can be reliably measured using FNIRS, she added.